Hello, 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 everyone, and welcome to the second day in the Varia track, where we discuss various subjects related to data science and everything around data. Personally, I think the best track to be in. Before I introduce our first speaker in this track, I just want to remind you about our knowledge partner Manning, who'll be giving free ebooks for the most active participants. So be active. It's worth it. So on to our first speaker. It's my pleasure to welcome Nir Barazida, who's the data scientist at Doug's Hub. Nir will be talking to us about notebook top to production, which seems like a very interesting subject and a very self-explanatory. And it's worth to pay attention because I know from different sources that Nir has some surprises for you, but also he holds a black belt in karate, so you don't want to be punished for missing some critical details. Nir, off to you.
Thank you so much, Pavel. And I promise I come in peace, so I won't be using any karate skills in this session. So it's so much fun being here today, and I want to thank Pavel for presenting me and for Big Data Conference Europe for inviting me to speak with you today. And I know that it can be challenging to join from home to a virtual conference, so don't worry, the DAGZUB team got your back. To make this session a bit more interactive for you, we're going to run a mini competition for 3 full swag package just for you. What do you need to do? Every time that you see the office GIF, write DAGZUB in the chat. Powell will see it, and the one who you will spot them first will receive a full swag package right to their home. So, with that in mind, our session today. Today we're going to talk about notebook to production, or more specifically, how we can shorten the time between notebook or our initial prototype in a Jupyter notebook to deploying our model to production. And we're going to do it using various MLOps tools and techniques. A bit about myself. So I'm Nir Barazida, an engineer at heart and a builder by soul. My background is varied. I major in structure analysis, but pretty quickly understand that data analysis is more of my thing. So I shifted my career to the ML domain. I was part of the founding team at Wolti, building machine learning algorithms to hack the way banks calculate your mortgage rates. So if you're planning to take a mortgage, ping me. And about 2 years ago, I joined the DAGZUB rocket ship, leading the MLOps team. And at DAGZUB, we're building the GitHub for machine learning, a centralized place to hold all the project components such as code, data, models, experiments, and more. And why is it very relevant to this talk? So our approach is not to reinvent the wheel wherever it's not necessary. We're building DAGZUB on top of powerful open source tools and adding a unique Git flow on top of them that enables full reproducibility. And in this session, I'm aiming to bring you the essence of what we've learned over the years about using Jupyter Notebook in a reproducible environment that will help you to scale your work and move faster to production. And so far, the hypothesis that had the highest statistical significance is that the best way to get data scientists' attention is by using 3 phrases: notebook, production, and MLOps. And today we're going to have them all. Jupyter Notebook was born out of the IPython back in 2014 and has rapidly grown in popularity among data scientists to become the de facto standard tool for exploratory analysis. To give you a sense of its impact, Jupyter was awarded the 2017 ACM Software System Award, a prestige honor shared with Java, Unix, and the web. However, if you're going to explore some of the MLOps communities, you might get the impression that notebooks are all that is evil in the world. And they might have a point. So, with notebooks, we can run out of order code and edit the cells after they have already been run once. a huge disadvantage for reproducibility. And it makes us put a lot of effort into tracking the kernel state when executing an experiment. Behind the scenes, Jupyter notebooks are basically a very, very, very large JSON files, also depends on how spaghetti your notebook is, that can't easily be diffed by Git and makes the reviewing process very hard and so the version controlling process. Last, the code hosted in the notebook cells is not callable outside the notebook and can't be tested or reused easily. So why are we even using Jupyter notebooks? Let's just throw them out of the window and go back to the good old IDE. Well, notebooks are a great tool after all that gives us superhuman abilities. They give us an interactive way to work with our code. They have built-in visualizations and we can see the results next to our code. This is also beneficial for communicating our work to technical colleagues or not so technical stakeholders. All this means that Jupyter notebooks are really good for quick prototyping. So now that we agree that notebooks are great, but also have some disadvantages, how can we make more efficient and use of them and overcome their drawbacks? So at DocZev, we conducted a user research, interviewing hundreds of data scientists, MLOps engineers, VPs, and CTOs, and found that when using Jupyter notebooks and following 6 simple principles, you can dramatically improve productivity, scalability, and reproducibility. And the main focus points that we want to have here, or the 6 principles, are first and foremost, we want to host our code in modules outside the notebooks and not in the notebooks. Version everything. Have peer review on our work. Track experiments and save them to a database. Use task-oriented notebooks. And keep track of our environment settings. And all of this sounds very, very good, but how does it look in practice? So I want to take you on a short tour of how we build a project here. So let's take a common scenario where our team lead just got off the phone with the CEO and there's a new project in the funnel. Save the planet. Surprisingly, the CEO wants it in production by end of week. This is a freaking game changer. So what are you going to do? You're going to roll up your sleeves, put on your headset, find the perfect gem for the task, open a new desktop, and go get some coffee. No, I'm kidding. You're going to probably download the dataset to your local machine, open a new notebook, and start exploring it. But hold your horses, cowboy. This is not your first rodeo. You've already created a one-of-a-kind, never heard of data analysis plots. But where are they? You start firing up old notebooks, scrolling through dozens of cells and outputs, looking into hundreds of code lines just to find that functions you were looking for. But although witnessing the outstanding work we did a few months back, it's highly time consuming. We want an easy way to search for the pieces of code we need and import them to our new project and reuse them. And this, among other things, is a very good reason to move our code to modules. So what do I mean by that? After getting our initial piece of code to do what it was designed to do, we want to refactor it into a Python function that doesn't rely on any global variable and takes everything as argument. So in our case, we created an amazing plot of global warming distribution, and it works. It does what exactly it was intended to do. Next, we're going to move it to a Python script and have everything import to that Python script as external variables. And then we're going to import that function back to our Jupyter Notebook code. And by doing that, we will unlock a world of opportunities. First and foremost, we'll be able to run unit tests on our function and make sure we don't fail in production, something that many data scientists neglect and don't really do before moving from the exploratory analysis or from building their model to production. Second, we can stay dry, meaning we don't repeat ourselves. We can now easily reuse our code in this project or anywhere else. And last, we can use static code analysis tools to flag programming errors and bugs. And now that we can move faster without breaking anything, sorry for breaking Mark Zuckerberg hypothesis, we can start exploring our data. But what should we do when reaching a good result or a dead end? Should we copy the cells to the bottom of the notebook just to make sure we don't lose them? Or should we Stone Age version our notebook by copying it and giving it a unique name? Final exploratory data analysis version 2 near. So only if there was a magical tool that enables version control with the power of going back in time. Oh, right, Git. Versioning our notebook with Git should be as intuitive as versioning our code files. Because when we're using Git, we're able to hypothesize in an isolated environment and research for better ways to improve our model or explore our data. We can recover previous work with a click of a button. We can use standard CI/CD tools, and the list just goes on and on. But aren't we neglecting something here? Remember, we're working on a data science project and we have code, but not only that, but also data, models, pipelines, and many more artifacts. And in most cases, the version of the non-code components is the focal point of our experiment. And therefore, we should be able to track and retrieve them easily. And for that, for versioning everything, we have a lot of options. So many tools emerged in recent years for data and pipeline versioning that are oriented for different tasks and use cases. And I think it's highly important to research for the tool that fits your need before choosing one. Some are very good for tabular data, other for unstructured data, another for deployment and containerizing our project. So really, I recommend doing the research before choosing the tool you want to use. And if you want to learn how to research for the tool, I highly recommend Dean's session, our CEO, about choosing MLOps tools from first principles. And it will guide you through the process that we're doing before choosing tools that we're integrating into DAGZUB. And I think it can give you a lot of insights on how to conduct a proper research. So now that we know that we want to version also our data and models, what will we benefit out of it? So by using designated tool to track our large files, we will be able to avoid ad hoc versioning, aka Stone Age versioning, by giving it different names. We'll be able to share versions of our code and models within the team easily. And most importantly, we'll be able to reproduce results with a click of a button because all the project components are going to be versioned. And last, you all know that we're using notebooks for visualization, and they can become very heavy or too heavy for Git to handle. And this is another great reason to use a versioning tool that can handle large files and maybe also use it to version our notebooks. So now that we broke down, explored, and tested our data to create the Mona Lisa of reports, really, it's a thing of beauty. So we feel confident enough to start processing our data. But what if we missed something? What there is an hidden bias in our work, or our hypothesis isn't supported by the data? Our work should be passed under the magnifying glasses of our colleagues. And this is an important step that once again is overlooked by data scientists because it's very hard to do. And we got to the point where we used to work as lone wolves without having other people to test us. And we shouldn't. And this shouldn't be the case. So we'd like to use our reviewing tools that enable sales and output diffing, and also the ability to communicate over our notebook with context. So adding comments on sales, diffing sales, etc. At DAGZUB, we're using NBDime under the hood to compare notebooks, and we develop our own mechanism for sales commenting. So you can now comment on sales, and also for parsing HTMLs and presenting them. I know that GitHub is using Review NB, and there's a tons of other tools and plugins out there that you might find useful. So just search for them, but know that you need them first. And by using them, it will help us to reduce the bias in our work and also find bugs in an early stage of the project or inefficient pre-processing method and avoid deploying buggy code to production. Great. So we explored our data, process it, and we're 3 days into the project and haven't run a single cell that contains fit. We want to train a model and we want it now. But just before we do that, keep in mind that we're conducting a research here. This is not a software development project. Experimenting without logging the parameters and the results is meaningless. We need to keep track of everything that is going on. It's not all about the end results, but the process. And we might need to go back in time and retrieve previous results. So, like with large file versioning, many tools emerged in recent years for experiment tracking. And in this case, I believe that it doesn't really matter with which hammer you choose to hit the nail, as long as you punch it through. So choose the tool that fits your need or that provide the features that you need or the visualization that helps you, and just use that. And once you're going to choose that hammer, it will help you to build a knowledge base of your project and your research as you go. Reproduce the experiment that you're running to some extent, and avoid recording of your experiment using spreadsheets or whatnot and ad hoc recording, because it's going to be built into your code. And now that the deadline is closing in and you find yourself going back and forth between processing and modeling, tweaking some of the parameters, rerunning the modeling, seeing the results, logging them, and you start feeling the heat from your boss to the point where she decides to add 2 new members to the task. Now we want to scale up the people on the task. But how can we do that? How does it really going to work? So Dean is going to work on cells 1 to 29. Gal is going to take cells 30 to 50. And I'm going to run cells 60 and above. Oh, and please don't run cell 14 because it takes forever to process and run it. We don't want to work this way. This is not a scalable way to collaborate with other people on any project, and it most likely result in stepping on each other's toes. We like to use, in this case, a designated notebook per task from the get-go that will enable us to scale our work or divide it between team members so we can work simultaneously on the same project. And this way, we'll be able, as I said, to scale up or down by increasing the man or woman power on the project, make the notebook easier to review and maintain, and have a clear structure to our project, because now we have a designated notebook for each of the tasks and we know how they work together and what is the general pipeline of our project, and can easily onboard it. Cool, so we're 6 hours before the deadline and we have one last training we need to run. But the person in charge of modeling just called in sick. Oh man, I just wish this week would be over. So what we're going to do, we're going to connect to our favorite cloud provider, no such thing, fire a monster machine, pull the latest version of our notebook, and hit run all cells. Wait, what is going on here? Error retrieving driver version, kernel reported driver version not implemented. Oh man, we're getting errors because our version of TensorFlow doesn't support the driver we're using in that machine. What the heck? So notebooks need to be reproducible in the sense that anyone on the team should be able to take your notebook or our notebook, even us later on, like 6 months from now, rerun it with the same input and get the same output. And to do that, what we need to do is keep track of our environment setup. And this way, we should be able to determine and recreate the environment that were required for the notebook to be executed. In other words, requirements.txt. But I highly recommend not stopping there and also containerizing our environment to ensure it's isolated and doesn't require any OS level dependencies, or that we have those OS level dependencies tracked somewhere in a way that we can use them later on. And in this way, we'll be able to fully reproduce our result by anyone on the team. We can iterate over our work and pick up the project from wherever you or other team member left it. And also we can hand off the project to the engineering team with all of its dependencies to deploy to production, or will we be able to do it on our own? Okay, wow. So with that, we reached to the end of the session, and we covered all the main or the 6 principles that we found that helps team to move to production faster from the research stage doing with Jupyter notebooks. And let's recap on those 6. So the first one was hosting our code in modules, and I feel like this is the most important one. And if you're taking anything from here or you want to find the place to start from, because we all know how hard it is to start changing our workflows. So I would say a good first step here is just taking all of our code that we're hosting on notebooks and move it to Python scripts and importing it back to our notebook. This will help us to reproduce, test, and reuse our code. We also want to version everything. So version our code, our data, our models, our pipeline, our experiment, everything basically. We want to have peer review on our work and project. So have people to review our work before moving to the processing or modeling or deployment stage. We want to keep track of all of our experiments and log them to a database. We want to also use task-oriented notebooks, so break down our spaghetti notebook into sub-notebooks, each one oriented to a specific task. So data gathering and annotating, data processing, EDA, modeling, and deployment, let's say, if you're using notebooks. And last, we want to track our environment setup to make sure that anyone can use our notebook and rerun it from scratch. And you can start incorporating these 6 principles in your work starting today. And I promise you that it will help you to move faster to production without the risks of breaking anything in the process. So with that, I want to thank you all for joining me today and helping me save planet Earth. Feel free to follow me on Twitter or LinkedIn. I would love to connect with you and learn about your use case, your workflows, the tool you use, and how we can either help you or learn from your use case and maybe provide better solutions on DAGSA. I want to thank you for joining. And at this point, I think we can open the stage for questions. Paul, take it away.
I'm back. Yes, let's absolutely open the stage. Thank you very much, Nir. So the first question is from Akash, and he asks, should we unit test notebooks? If yes, what is the best practice?
So what I recommend here is, and it connects to the first point of moving all of our code to Python module, is this way you can unit test each function separately, the same as using best practices for development projects, and simply use the Jupyter notebooks as the tool to either visualize our work, create reports, or in some cases, if you really want to use it for your research stage, just as something that you run end to end, and it also provides you the report, the outputs, and then generate also the model that is saved locally and versioned with the other tool. So for unit test, I highly recommend using it on your Python scripts and not your notebooks.
Right. Makes sense. Thank you very much. We have a couple of more. Stefan is asking, so do you finally run your Jupyter notebooks automatically in production?
So I don't recommend using notebooks in production. I know that a lot of companies are doing that, but in most cases, those companies are Amazon, Netflix, and those type of companies that behind the scenes build their own mechanism to using notebooks in production. And if you think about it, notebooks is very oriented for ML purposes and is not used in dev cycles or DevOps cycles. And they don't really play well in production. So instead of building or using unique tools for notebooks in production, I once again recommend building those pipelines in Python scripts or with different tools and use those scripts in production. So notebooks, like the mental model for notebooks is that they're there for building the reports and hypothesizing and like the sandbox for our project. But once we're ready with our code is stable enough, move it to Python script, use it as the core of the project, run unit test on it, and later on deploy it to production.
Hmm. Good tips. Thank you very much. It looks like Akash is really interested in the topic. So he has another question coming up. He's asking, so is Dugs Hub using Databricks notebook and associated infra in production?
So we actually, this is a very good question. We are integrated with Databricks MLflow tool. And what we provide is basically, I would say, I don't like say full support because there is also edge cases, but we basically provide a remote MLflow server configured with every DagZab repository. So you're getting a remote server out of the box with team-based access control that you can log your experiments and artifacts to, and later on deploy it using the model registry and deployment functionality that MLflow provide out of the box with DagZab. For notebooks, we support general any IPyNB notebook support. So if you're going to push it to DagZab, you're going to be able to see it, visualize HTML plots, and also play with them, diff notebooks, and also communicate over them, meaning you can comment on your notebook cells and build your knowledge base and use reviewing tools that we provide. And this is basically the scope of integration we have in Databricks, so MLflow by Databricks, and support for notebooks on DagZab. I hope it covered it, but if you have any follow-up, I would be happy to answer.
Okay. Yeah, please remember, guys, you can always reach Nir on the different media he provided. So let's jump to another person with a question. Alejandra, she says, so one of the things I dislike about notebooks is that because they are often run in their own local server, the auto-completion or the extensions to help with docstring, linting, etc. are not there. This is an afterthought that is often skipped. What do you advise against these problems? Good question, I think.
So this is hard because it depends which notebook you're using on which platforms. There's a lot of, let's say if you now want GPU and you're running it with, let's say Colab, then the plugins and add-ons won't be accessible there. This is a very good question. And I feel like there is no easy solution in this case. So if you're using it on your local machine and you're using those plugins and it helps you, maybe it can help you in the process of building a better, a more efficient code. But if you're going to move it to a different platform, there is some dependencies or limitations that it have, so you can't really use it there. Once again, in some sense, moving to Python script can be the case because IDEs have all of those capabilities, and you can find it there, and it won't require you to lose those extensions. Trying to think of a solution on my feet here because this is something that I haven't accord or had a chance to a challenge to hit. So if I'll have a good solution, I will definitely ping you. Feel free to connect me on LinkedIn, And let's chat it offline. I would love to think of a proper solution, Akanda. Thank you for asking.
Good. Okay, so another question is from Claudio, who's, by the way, one of the winners in your competition. So
Woo!
he's on fire here. Yeah. So the question is,
Nice. You're
are
gonna get
you
this T-shirt, by the way.
nice, looking good? So the question: are you applying any best practices for dry? How are you reusing existing functions between multiple notebooks?
So the functions are hosted on Python scripts, and those scripts are, let's say, the Save the Planet project. It's going to be under directory for EDA, let's say, if I'm doing EDA now. So under a directory for EDA, I'm going to have multiple scripts there, each one for a different purpose. And this way, I can easily know or go back to those functions, copy and paste them to different projects, or in this project, import it in different cells or in different notebooks. Because basically, I don't need to import the code from one notebook to the other. I have it in a Python script and I can import it to multiple Python or to multiple Jupyter notebooks. And this is a great advantage when using task-oriented notebooks because you do want to import your code to different notebooks. And let's say the processing step is using some function as the EDA step, and you both want to use the same function, but you want to also enhance it and use the enhancement in both of the notebooks, right? So if the code piece is going to be duplicated, it's going to be hard to maintain it. But once you have a single source of truth, you have one function hosted in one Python script, and you import that function, it helps you for reusing and importing to different purposes.
Hmm. Okay. So it looks like we are down to the last question from Akash again. He's asking, is Doug's Hub leveraging GitHub Actions for running some pre-checks while deploying notebooks?
I feel like Akash is a secret agent here because he's asking all the good DAGSUB questions. So DAGSUB is integrated with GitHub. We name it the DAGSUB Connect. And basically what you can do is connect the GitHub repo to DAGSUB. And in this case, you will keep your Git server on GitHub, but we're going to have an agent that is going to basically clone the repo to DAGSUB servers and present you all the content of your Git repo also on DAGSUB. And every time that you're going to push something to that Git repo or create a pull request or open an issue or close an issue, it's going to also be seen on DAGSUB. And you can manage pull requests and issues from both platforms. And the added value here is that you can use the best of both worlds. So on DAGSUB, you can use our data management capabilities, diffing, communicating, etc., our experiment tracking server, our label studio workspace, and so on. And on GitHub, you can use the GitHub actions. So let's say you have an action that every time you are merging something to the main branch, it fires a training process or a deployment process using GitHub actions. So you can do it from DAGSUB. You can review the pull request from DAGSUB. In the pull request, which is a data science pull request, you can diff data, notebooks, communicate over these things, etc. Close the pull request. It's going to also close it on GitHub, create that merge from that branch to master, and then it's going to kick off the GitHub actions to either fire the training process or the deployment process. So this is our integration with GitHub and GitHub actions.
Great. Oh, really extensive answers. Thank you for that. It looks like these were all the questions from the audience, which is cool. We still have a couple of minutes left, and I just wanted to kind of retrospect a little bit because it's crazy how notebooks, the journey that they've been through. I remember first time when they appeared. I tried them and I got a bit discouraged. Like it was pretty much you couldn't do anything. Like even debugging was really problematic. So I'm a hardcore IDE guy. I use PyCharm, But what's your, like, when you look back, what's your kind of journey with notebooks and how they evolved over time?
Same. So I feel like notebooks in the early stages were lacking a lot of core capabilities, and they still have some limitations. So still debugging is not as easy as debugging in an IDE, right? But they also give us, as I mentioned in the session, superhuman abilities for reports and quick prototyping. So if we're using them for the purpose of what they were built for, which is building reports, prototyping, like sandbox experimenting, then I feel like they have huge benefits. But when using them for development purposes, it kind of misses the point and it's hard to do. So I feel like there were a lot of good extensions and capabilities or enhancement that were add on to notebooks in the past few years, but I feel like they changed the course or the main goal of those notebooks. And I feel like also Google Colab maybe had a huge impact on it because it provides us the ability to run or train notebooks or train models using strong computational power. But it changed our mindset that we should develop our code in notebooks. And I don't feel like this is the case. I feel like we need to import our code to those notebooks and use those GPU powers that Colab and other providers are providing us for training. So it's good that we got all these extensions, but we should keep in mind that notebooks, or the main purpose of Jupyter notebooks, is for prototyping and reports and not developing our code there, because it kind of misses the point.
Yeah. And I think this makes for a great final thought, really, of the session. So, Nir, thank you very much. It's been a pleasure. Great presentation, and yeah, stay on for the track.
Thank you everyone for joining. It was a great pleasure. Once again, if you want to connect on LinkedIn, Twitter, hit me up, and I would love to hear about your use case, about the things that you're dealing with, about the tools you're using, or if you have any challenges that I can learn from or support. I'd love to do that. And for the winners of the swag challenge, Powell will send me your full names. If you can share your emails with Powell, that will be awesome. It will be easier for us to reach out to you, or DM me on LinkedIn, and I'll make sure that the swag pack will reach directly to your home. So thank you everyone, and thank you Powell for hosting me and for the Big Data Conference Europe.
Yeah, the way it's going to work is we will just reach out to the organizers and ask for the email addresses of the people that won, because they may not necessarily know that they won
They
right
won.
now.
Yeah.
So let's do it like this. Good. Thank you very
Okay,
much.
cool.
Catch you later.
Thank you everyone. Have a
Bye.
great day. Bye bye.